We want to thank you for the time you took to come to this conference. My name is Martina Leon, and I am a project manager at Advanced Renewable Technology International, ARTi. First of all, in the next slides, I would like to go over a brief introduction about our history and technology. Also, the pyrolysis of digested manure residues and its environmental and economic benefit using ARTi's biochar production units, and as well some other biochar products. Finally, we will show how we can evaluate biochar by its chemical compositions. ARTi is an international company founded in 2013. We design and build cutting-edge pyrolysis systems for the production of biochar. We produce biochar, and we sequester CO2 as well. Additionally, we perform some research and development for our customers and as well internally on a continuous improvement process. Our company has several years of experience in the market and has expanded operations worldwide with a multiple academic and cultural background team. Let me go over why we think it's important to address manure as one of our main feedstocks. A special report on climate change and land reports from the Intergovernmental Panel on Climate Change shows that a range from 10.8 to 19.1 millions of tons of CO2 are emitted per year. This represents 21 to 37% of total emissions in the world. Manure is responsible of 10% of all the global livestock greenhouse emissions. So in 2018, 125 million tons of manure were produced, of which the 27% was treated in management systems, and from that 27%, 7% of those had a bad treatment, which represented a loss mainly as ammonia. So the composting treatment has been a common methodology to use manure as an organic fertilizer, although it has certain drawbacks, such as 14 to 51% of the organic carbon and 16 to 74% nitrogen content of the raw material is transformed into CH4, CO2, NH3, and N2O. But how can we provide a value to the manure for both preventing emissions and creating revenue? Well, with ARTi methodology, we are able to produce value-added products from the biomass residues, and as well, we can produce biochar. ARTi's reactors are tailored for each client's need and operations. The reactors that ARTi offers have different levels of automation, from manual to fully automated. Their customizable design makes them very flexible to adapt to each other of our clients' requirements, and as well for the characteristic of each feedstocks. They are scalable, meaning we can include from 1 up to 5 train reactors, and this really depends on the quantity of feedstock that our clients have. They are transportable as well, since everything is housed in a 40-foot container, such as in the picture that you can see over there. The variety of feedstocks that ARTi reactors can pyrolyze is really extensive, and ARTi systems are also capable of producing the following co-products. So we have bio oil, carbon credits, and electricity generation. And this electricity generation we can produce by the waste heat, by the use of the waste heat that we have. So here is one of the pictures of the reactors that ARTi manufactured in the past. ARTi focuses a lot of effort in research and development, as every material will behave differently, as the properties and external variables will affect the final results. So some of the feedstocks that we have pyrolyzed are forestry residues, agricultural residues, and as well industrial residues. Great. So how do we give value to the biochar? We have to go through its chemical composition. Why? Because sometimes we can see that we have too much organic value and less NPK, or lots of NPK and less organic value. So for these, we will focus on two main variables. First of all, the organic carbon, and as well for the nutrient content expressed in NPK. First of all, for the organic carbon calculation, we monetize by transforming the carbon element into CO2, meaning in that 1 ton of the carbon, we have 3.65 tons of CO2. Afterwards, we gather some information from the market value from the CO2, which is $100 per ton. And then we got the conversion that is 367 dollars per ton. As an equation to be evaluated based on the organic percentage of its feedstock to be analyzed. So we can equate the following. For $367 per ton, we multiply by the organic carbon percentage that we get for each project. Now moving on, we have for the nutrient content, it is important to mention that the NPK actually stands for N, P2O5, and K2O, which is commonly used to evaluate the fertilizers that we have. To get the value of the NPK, we have considered products for the market, meaning we consider the urea for the nitrogen, triple superphosphate for the phosphorus, and potassium chloride for the potassium. So with the market index of these materials as shown in the gray spot at the right, we make the conversions by using the molar weight of the NPK and the market products that we mentioned before. This is equal to $1,498 per ton of nitrogen, $879 per ton of phosphorus, and $1,083 per ton of potassium. However, we have also expressed set values in N, P2O5, and K2O by the use of the conversion factors on the gray spot at the right. And those will be the prices that will be afterward multiplied by the NPK percentages in each case scenario that we have. So based on ARTi experience, we want to show you 3 different case scenarios for 3 different feedstocks. First of all, starting with wood chips, moving into cocoa shells, and finishing with horse manure. The 3 of them are based in R&D trials that we have executed, and as well, they are evaluated within a laboratory analysis. So, well, starting with the wood chips, this is the scenario of the wood chips. Actually, we have some assumptions. First of all, the operating days per year of the project is 281 in a 24-hour basis. We are not taking into account the weekends or holidays. Then we have the biomass throughput, which is 8 tons per day. The revenue streams of the project that are the biochar sales and the carbon credits. And the carbon credit price will go for $150 per credit. For the trial information, the biomass moisture content is 37%. The temperature is 700 C. The biochar hydrogen to carbon, meaning the H2C ratio, is 0.34. The biochar yield 30%. The organic carbon 90%. And the biochar produced annually is 425 tons.
Should try to unmute yourself again. Now it should work. Yeah.
Great, there we go. Sorry. So well, for the presentation, for the wood chips as scenario, we have, the N value for 0.57%, the P for 0.02%, the K for 0.23%, and we have also converted these values to N, P2O5, and K2O for you to, if you want to make some conversions as well. So for the main challenges that we faced during the wood chips trials are the moisture content and the particle size are really high. Some of the benefits are the transportation and the eco-friendly that is these products. And for the results, we get that for the organic carbon value, $330 per ton. This organic value we calculated based on the $367 per ton of C that we had in the last slide, and the 90% of the organic carbon that we have of the wood chips. And then we have the nutrient content value. We had the N for $9, the phosphorus for $0, and the potassium for $2. Actually, this value as well, we multiplied by the values that we got in the last slide for the nutrient contents. And this gives us a total of a nutrient value of $11 per ton, and a total biochar revenue, including the organic carbon value and the nutrient content value, for $341 per ton of biochar produced. All right, so we have for the carbon credits. For the carbon credits, we actually develop an LCA, which is based in an ISO standard that is accepted by the Puro.Earth methodology. And for this carbon credit ratio, we take into account the moisture content, the organic carbon, the H to C ratio, and as well the yield. So for this particular project, we have the carbon credit ratio for 2.6, and the carbon credit revenue is $309 per ton. So for the total revenues, including the biochar valuation and the carbon credits, we have $650 per ton of biochar produced for the project. And we have a positive internal rate of return for the project of 10%. So moving on, we have cocoa shells. For the cocoa shells, the assumptions that we did are the same ones, except for the biomass throughput, which is 7 tons per day. All right. So for the trial information for the cocoa shells, we have the biomass moisture content is an 11%, the temperature 700, the biochar hydrogen to carbon or H2C ratio of 0.26, the biochar yield 23%, the organic carbon 59%, and the biochar produced annually for the project is 455 tons. For the total nutrient values, we have the N for 2.37%, the P for 0.85%, and the K for 6.57%. As well, we have converted to N, P2O5, K2O. So one of the main challenges that we face for the cocoa shells is that they decompose easily since it is an organic material. For the benefits, we have, it is really easy to handle the cocoa shells. The particle size and the moisture content are really low. So great, for the results of these tests, for this scenario for the cocoa shells, we have that the organic value is $217 per ton. The nutrient content value for nitrogen is $36. The phosphorus $7, and the potassium $71. So we have a nutrient content value of $114 per ton. And that gives us a biochar revenue of $331 per ton of biochar. And for the carbon credit side, we have the carbon credits ratio of 1.32. The carbon credit revenue of $198 per ton. And for the total revenues, we have $521 per ton of biochar produced. All right. And as well, we have a positive internal rate of return of more than $7 of 7%. Sorry. All right. So moving on, we have already the horse manure. So for the assumptions for these scenario, actually we have the same ones from the last ones, except that we have the biomass throughput for 7 tons per day. All right. So for the trial information, the biomass moisture content is 26%, the temperature 700 C, the biochar hydrogen to carbon or H2C ratio of 0.29, the biochar yield for 32%, the organic carbon for 61%. The biochar produced annually is 455 tons. And for the nutrient content values, we have for the N 84%. For the P or phosphorus, we have 0.85%, and for the K 3.53% as well. We have converted to N P2O5 and KO2. The main challenges that we face with the horse manure is the handling expenses, the high ash content, the moisture content is really high, and as well the greenhouse gas emissions that we are facing. And some of the benefits are the waste management that it's really easy to do. For results for the biochar valuation, we have an organic carbon value of $224 per ton, the nutrient content value of $13 for the nitrogen. For the phosphorus, we have $7, and for the potassium, we have $38, with a total nutrient content value of $58 per ton. And the biochar revenue will be including the organic carbon value and the nutrient content value for a total of $282 per ton of biochar. And for the carbon credit side, we have a carbon credit ratio of 1.50 and the carbon credit revenue of $225 per ton, which gives us a total revenue of $507 per ton of biochar and a positive internal rate of return of 8.5%. So for the manure biochar, we have a payback period for the project for it is 43 days with a project period of 10 years and a carbon credit ratio of 1.5. How did we do this carbon credit ratio? Actually, in the diagram that you have at the right side of the screen, we have that 0.3 was in the gray column. It is the total CO2 that we emitted in the process of manufacturing, transportation, and as well for the production of the biochar. The dark green column is the 1.8, is the total CO2 that we sequestered while we did the biochar. And the light green column, the 1.5, is the net, the difference between both, and it is actually the carbon credit ratio that we are able to sell. All right, so based on the previous results, the total revenue and the internal rate of return of the wood chips is the highest one versus the two other scenarios. However, if we compare the internal rate of revenue between the cocoa and the manure has one that has the higher percentage, although the NPK values for the cocoa are much higher. On the carbon credit side, since it depends on the hydrogen to carbon ratio, the manure is not the best one, but it still has revenue. So the internal rate of return of all of the projects have a positive rate of return of more of the 7%. Great. So looking at the summary graphs, we have the NPK value for the wood chips with the lowest percentage actually. And the cocoa has a good advantage on that side, as well as the manure, as you can see. For the biochar composition of the manure actually has the 61.2% of the organic carbon, which is a positive for the carbon credits. And the total ash is 38%, and the total nitrogen is of a 0.8%. This makes a positive return for the manure and other feedstocks by using ARTi systems in the market. Please, we need to take into account that these numbers are based in the ARTi 1-train reactor. If we scale it up for the 5-train reactor, which is the biggest unit that we have, those numbers might double or triple. So in the previous exercises, it shows how the NPK values can be also valorized in biochars that do not have a high organic carbon as agricultural and industrial residues. So finally, we have ARTi offices in Iowa and in Quito, Ecuador. As you can see in the map, we have reactors, equipment, and consultancy services all around the world. So please contact us if you want further information on the projects, and we are really happy to be here with you and share our experience. Thank you very much.
Thank you, Martina, for your presentation. Very nice to see the economic side of things here. So you got a couple of questions in the chat. I will start with them. So the first question was, did you try different kinds of manure, or do you have any experience if dairy manure would also work, or if you have any information on that?
Great. Thank you for that question. Yes, actually, we have some experience with horse manure as well as cattle, and we have as well experience with some chicken litter. And all of our projects, I really believe that they have a really a high internal rate of return.
And a follow-up question from my side. So I understand the calculations, but what were the feedstock costs you chose? Because I mean, biochar production always depends on how much you pay for the feedstock. So similar to the question from Hanu Salmi, how are the material costs evaluated? So how much did you pay for the wood chips or for the manure to calculate the revenue?
Great question. Actually, for the manure, cocoa shells, and wastes, actually are wastes that our clients have either in farms or in other spaces. So what we calculate over there is actually the transportation costs for the project. But for the feedstocks as a whole, that is something that our clients do have as waste.
Okay, so the calculations are without feedstock costs.
Yes, exactly.
Okay, and then there was a question from Sylvia. So as manure is a nitrogen-rich material, do you know what is the fate of nitrogen during pyrolysis, and can you measure it?
Sorry, could you repeat the questions? I didn't hear.
What is the fate of nitrogen during manure pyrolysis in your reactors, and do you know where it ends up, the nitrogen?
Great. For that question, I would like to invite Liz or Diego, my teammates. They are actually part of the economics manager of ARTi. So please, if you can turn on your microphone.
I think it should work now. I have to let you do that.
Or yes, I think they are having problems with the microphone. So if we can go to the next question and afterwards we can.
Okay, so the next question was from Edmund. Is the manure dried or wet during the pyrolysis process? I think you had the moisture content somewhere of the manure.
Great question. So actually for our feedstocks, we consider in a wet matter basis. For our reactors, we need a moisture content less than 20%. So what we do, first of all, is drying the feedstocks for about 15% or less of moisture content. So yes, these are scenarios based on wet matter basis.
And the last question from Stanley is ARTi a carbon trader, or do you work with Puro, or do you trade the certificates?
Great, excellent question. Actually, we've been working with Puro.earth methodology, that certification. However, it really depends on our customer willing. Sometimes, yes, we have worked with Vera, and as you may know, they ask for different things. But yes, we are open to work with them as well.
And really last question from my side. So you mentioned that you can produce bio oil. I was wondering what happens in the normal ARTi reactor. Are you combusting the gas phase and the liquid, or are you actually collecting the bio oil?
We are actually collecting the bio oil. So it is an extra process that we need to include. And the equipment needed for that is a bio oil collecting system, actually.
And do you have is there any market so far? Because as far as I know, bio oil is a pretty nasty substance usually. Is there any use that ARTi, or is there some application ARTi has in mind for that, or?
Great, yes. Actually, for the market for the bio oil isn't that big. So for our clients or customers that are using the bio oil, they are using as well for a fertilizer to use it with the biochar.
Okay, so you put the bio oil back to the biochar and then use it. Okay. So I think that we are perfectly on time. So half an hour now. Thank you very much, Martina, for your presentation and also for the answers to the